Hello, friends. Joe here. Hello. Welcome to the Tinybird stream. I don't know. I feel like we should just jump into this today. I have a fun little demo we put together over here at Tinybird, and I would love to just walk through it with you. So first of all, my name's Joe. I'm a developer advocate here at Tinybird, and I am just excited to be here. I haven't actually done a live coding session for quite a while. I have the demo prepared, so I'm just going to pray to the live demo gods out there that everything goes okay today. We're also going to be doing some just live testing here with some new stuff I've put together. So come along for the ride. I hope you get to see the blood, sweat, and tears that goes into producing demo applications like this. Let's see here. I'm going to wait for some folks to stream in here. I would love to get your participation, actually. I'm going to send everybody in the chat a little thing here. Okay, great. I'm just checking Slack. Oh my gosh. Prashant just texted or just Slacked me and said he's streaming on the big screen. So I'm lucky that these streams aren't in 4K because I don't want everyone looking at my pores here. But 1080p is good enough. I'm going to post in the chat here today a little demo if you want to follow along at home. So I'm going to post in the live stream. So if you check the chat, I just posted a gist. If you want to follow along today, what we're going to be doing is putting together a Datadog-like infrastructure monitoring tool, but one that you can roll your own, and we'll show you how to build it and adapt it and then actually use it to actually set up an alerting system with APIs. The script I have posted over there, actually, maybe I'll share my screen here. Let me pop up everything. Great. Okay, and present screen. Okay. There we go. All right. Hope this works. All right. Can everyone see this? If you want to follow along at home, what we're doing is we're going to set up we have a Kafka topic, a Kafka stream set up. But we're going to be streaming in data from a bunch of different computers from a bunch of people at Tinybird. We're running it right now live while we're streaming. And if you want to also participate, you can also run the script locally. All it's going to be doing is sending some basic computer information, including the OS, an average and minimum, free space, disk size, whatever. And sending it back to our Kafka stream every second. So we're going to be consuming these topics and then doing some data analysis on that and then producing APIs from that. If you're not familiar with what Datadog is basically think of it as a giant notebook for keeping track of all of the CPUs or all the computers in a system. This could be like a server farm. If you're running a system that's just monitoring your employees' computers for any potential issues, this could also be used for that as well. There's lots of different options for that. I think of it as a notebook you have at home that you can kind of write down the status of your toys in a toy box, and it's just reporting on those in real time. And you can set up alerts for that if any of your toys break in the moment. Alerting tools like this are super important for real-time analysis because we want to know as quickly as possible if a system or toy in our toolbox goes down, right? If you guys have any questions, or if you want to follow along, go ahead and follow along with that gist in there. Ask me if you have any issues getting it up and running, just yell in the chat. We'll try our best to help you out with it. But it should work. So, yep, again, just a simple little script, and the script is down here at the bottom too. We're just sending this basic information back to us. All right, cool. So let's jump into this. You can set this up at any time too, and please just write a nice little message to us. Nothing too, nothing too vulgar or anything like that. But we have a little Kafka topic set up that's ingesting these in real time. I wonder if, is this updating in real time on Confluent? I'm just going to give an update here. Refresh it. Let's get an overview. And you can see that we are consuming and using these in real time here, which is amazing. Oh, this is awesome. Great. So we have a bunch of stuff coming in. And 1808, yeah, that's the current time. So you can see these are currently coming in from a bunch of folks at Tinybird who are running the script, including me. So what I want to do is actually go through and setting up how to integrate Kafka streams into Tinybird in real time. And again, we've been doing a lot of work on Kafka this week. And I think we're actually in Kafka London this week. So if you're out there, come say hi to us at our booth. We'd love to give you some swag. We'd love to say hi. And we'd love to hear about what you're working on. If you can't make it out to London, I'm based here in the US and can't make it. So you can just hang out with us online and we can learn a little bit more about Kafka. I have to say, before putting this demo together, I was not a Kafka expert. I've been spending a lot of time trying to like dig in and learn how to actually make production scalable Kafka environments and actually using them. I find that Kafka message queues are really useful for real-time data streaming. The hard part is actually doing something with that data. I think especially the Confluent, Red Panda, Upstash, they do really great job of making it easy to set up a Kafka environment, but actually using that data can be really tricky. And on top of that, integrating that Kafka stream with other data sources is also traditionally really tricky. Let's jump in. I've got a little thing here. I'm going to actually set up a new clean workspace here. And let's call this like, this is our Datadog. What is this? We'll call this like a we'll call this mini Datadog. How about that? Mini Datadog. All right. And I'm just going to create a workspace here. Juiced. Uh-oh. Looks like Juice is running the script locally, made a little reference. If anyone gets this reference, let us know in the comments. Okay, so we have a brand new, fresh Tinybird. I'm going to call it Tiny Dog here, at least once this stream. David, thank you so much for reminding me to zoom in. I always forget how much larger I need to make my screen in real life. So first thing we're going to do is actually set up our workspace, and then we're going to bring in our data source in real time. Okay, cool. So what we're going to do is just choose our data source. We actually have a built-in Kafka and Confluent connector. Amazing. And all we have to do is get our Kafka connection information. So I got to remember how to do that on here. Otherwise, I have it. Let's see, configuration. Here we go. Great. Show complete. Is that it in here? Nope. Okay. Okay, let's see here. I can't remember where it is. I have it saved over here. That's totally fine. It's in the gist. So I'm just going to copy the information I have in here. So this is basically the information of where our server is. I will be deleting these keys afterward, so don't even try to steal my Kafka topic here. I don't know what you'd want to do with it, but you know, we are going to be nuking this after the fact here. So we got our username and password. Whoops. Right, plain. And we're going to hit next. So next, we've authenticated to Confluent, and it goes and gets all the topics that we have saved on here. So I'm going to go find the topic that we're playing with, which is our infrastructure demo. So I got to find, looks like it's not in alphabetical order, infrastructure monitoring demo. There we go. So I'm just going to hit next. We're going to import that in. And you can choose whether you want the latest or the earliest. I've had the Tinybird employees running this script now for a couple hours. So I'm just going to ingest all of the records from the beginning into our Tinybird cluster. And let's see, what should we call this? We should call this like events from, I don't know. I know it's some other folks out there are still running this, but we're just going to call this events from Tinybird. And you can see here, we can actually see all of the different things that we're importing from that script on here as well. Cool thing about this is it does automatic type checking. You can change this, but these look fine to me. So I'm just going to hit create data source. And that's going to import all those events in real time into Tinybird. So, and boom, there we go. We're already importing all those, and it's super quick, super quick. We're built on top of ClickHouse, so importing data sources like this is it's nearly real time, like nearly instantaneous. We're able to import those and keep track of all the records that are coming in both at the same time. And you can see here, hopefully this will start picking up here, but we can see all the different messages coming in every single second from a bunch of different folks here at Tinybird and from you guys out there in the wild as well. And again, if you guys want to follow along, go ahead. We would love to have you submit some messages to us as well so we can play with them a little bit. So we're running the script locally from a bunch of different computers, collecting them. Now we want to actually like do something with the data. We have all this Kafka data. We have all this historical data and this data that's happening, pulling in real time. And I wonder if I refresh it, we can start to see that little, I love just seeing the little graph here just tick up. But to do that, we do that with pipes in Tinybird. Pipes are basically allow us to write SQL commands to select data from a bunch of different data sources and then do some SQL commands on it to output, something new. So let's check that out. I'm going to make a new pipe and let's call it like exploration pipe. Let's just play around to see what kind of data we get here. So default, we're just going to select everything from our new Kafka event source here, our data source. And you can see here, boom, all the stuff is just popping in. This is everything that's loading in. Lots and lots of data, but a little bit, oh, did not go? Let's see, let's do exploration pipe. Let's just go through and get all the data or like kind of refine it a little bit. If you guys don't know, best practices for writing SQL commands, especially performant ones in real time, is doing an initial filter on that data. So if you can filter the data up front before you start doing some data processing on it, it makes you have to process less data, which can make your queries run faster. So select star, easy. But the more you can filter out and kind of group and whatever, the better off and more performant your queries will be in the long term. So let's just go through. We're going to go and nickname. Let's go get some of the stuff here. Team. Love this about this Tinybird too, but it does this autocomplete based on the fields that are coming in from your data sources. So I don't have to go and check every single time, which is amazing. Text, CPUs. I think we also have, disk space free. Oops, keep forgetting those commas. Disk space size. And we have mem free and mem size. Great. And then let's do an order by timestamp. So we're going to get the most recent ones up front, descending. There we go. And we can run that query. So now we're going to be seeing the most recent queries. According to my clock, this looks like it's pretty accurate. So we can keep running that, right? We're going to get the most recent things every single time we hit that run button. Okay, so we've got all our data. We're able to start playing around with it, order it, kind of change it up a little bit. I actually kind of want to see what my coworkers are writing to me in this, in the scripts. I want to see what all y'all are writing too. So and also really cool about this too, we call these nodes. They're similar to what you'd see in a Jupyter notebook, but nodes allow us to write discrete functional SQL commands that filter. And I find that using nodes makes it much easier to debug, and it also makes it much easier to read as a human being what's happening at every single step. So for example, I'll show you here. So we're going to do distinct, and I want to see all the distinct texts from the previous node, which I think we called all columns. So this will allow us to see all of the distinct messages everyone's sending to us. Hey, right? which is really cool. And we can actually like label it. I think of these two as, think of them as like functions when you're writing with programming, right? A function is a discrete, small, simple thing you do, and you want to keep those small and readable so that other people can digest them. I find that really complex queries can get really unmanageable, and it gets hard to debug them at scale when they're just massively lumped together and not really labeled very well. You can even write little descriptions on here too, which we don't have time for today, but that's totally fine. All right, let's see here. Do we have any cool... I love paella and nothing else. You know, the all paella diet. I love it. Keep it simple. Speed wins. Let's see here. And juice. I'm seeing if I can find your what is this one? I think I found the Kafka. I think I found the metamorphosis. Juice, I think we found you. I love that. Thank you. And just streams of beer. I think this was mine. Something simple. All right. Cool. So I got some cool messages in here. Let's do some more, though. I want to write another query here. And I want to start breaking up the events that are streaming in from all the different CPUs in real time. And I kind of want to see what those look like. So let's do a, let's switch this up a little bit. Select, I want to kind of group these together. Timestamp. As key count. So this will group and give us a count of all of them, all of the different events happening by time. So from all columns, that's our node above. And then we're going to do a group. Kept wondering who Juice was. Oh, Yoast. I'm so sorry. Oh, my. Thank you for correcting me. I appreciate that. All right, let's see here. So we're going to group by T and order by T in descending. Great. Oh, no, let's see here. Oh, I think I forgot the from here. Nope. Okay, what did I do? Count. Trying to see here. Thank you. Thank you, Yoast. You guys are too kind. Too kind. Oh, I think it was my comma, actually. Yeah, it was my comma. It's the, you know, it happens with real-time live coding. You're going to get some, you're going to get some, let's see, you know what, actually, I'm going to try this. There we go. I'm going to make my screen a little bit bigger here. So you can see all the events happening in distinct time chunks here as well. And I'm going to just label this as well. Events per unit of... Problem too with reading things. My mom always used to say you should never make fun of somebody for mispronouncing a word because it means that they read it in a book, which I think is really true. If you don't know how to pronounce it, just means you've been reading names on Slack or on chats for too long. All right, cool. So events per unit of time, great. And you know what? I want to see what all of the different events here are coming from, or like who said what. So we're going to start blaming people here. So distinct nickname and text from events. Great. Let's try this. All right, cool. Now we get to actually see who said what. Yep, there we go. Amazing. Amazing. Wow. Great. All right, cool. So that was just kind of playing around a little bit with the data, but that's not quite Datadog, right? We don't quite have a, oh, cool. We got some extra, comments here too. I love these ideas. Keep them coming too. We can try to figure those out. I'm going to go through and actually write some Datadog monitoring pipelines here. So we played around a little bit. We'll see what's going on here. But I want to actually start, checking out. So let's do a laptop check. So let's actually write some code to actually start getting some interesting data from all of this. So I want to get some insights filtering based on the percentage of memory that the people who are running the scripts computers have. So let's go ahead and actually do that. I want to do a mem size. We're going to select that data. Remember, you want to try to filter as much as possible up front to try to minimize the impact and increase the performance of your queries. We do scaling on these endpoints with serverless endpoints, but still, SQL best practices and good SQL hygiene is going to be your best friend here. So we're going to round up mem free divided by mem size times 100 and round to the second percentage point. And this will be our free percentage left on their computer. And then we want to do a nickname, OS, and let's get a timestamp as well. Great. Okay. And that should be good. Free percentage. Now we can see the percentage of our employees' computers that is currently free, which is great. Look at this, 26%. Who knew that live streaming also decreases the free percentage of CPU available on a computer? Who knew? Learning things all the time. Let's get filtered. Let's do even more. So let's name this one too. Laptop checks. And we'll call this filtered data. Let's get the average time. Let's do some. Let's filter by the. We'll start rounding up to some of the data here. So we're going to do to start of 15 minutes. So we're going to start selecting the data or kind of grouping the data by 15-minute intervals. And we're going to pass that timestamp in. Timestamp as hour. Okay. And then I want to get the nickname and OS. And then also going to get that round average free percentage that we had defined above. So free percent. Yeah, and then we just do, because I changed the name here, it doesn't know which node we're collecting it from. So I'm just going to change this so our autocomplete works correctly. There it is, free percentage from the previous node. And we're going to do the same thing. We're going to do a second place and as free on average. Okay, great. That looks good. From filtered data. Group by our nickname, OS, and then order by our sending and nickname ascending. Okay. I think I'm missing another parenthesis there. There we go. Okay, so now we can start grouping together the averages based on per hour, right? We're going to find the average of within an hour to the 15 minutes. And we can find out the averages based on kind of that grouping by hour and who has what. Okay. All right. So yeah, grouping by hour. That is awesome. Okay, let's get to some interesting stuff here. We can always make, let's see here. Well, I'm just going to name this first because I want to use this on the next one. So average by time and nickname. So this next step, we're going to actually set up a filter on here to show with CPUs with really low memory. And then we're going to be setting up a API from that so we can actually consume and use that. And then I'm actually going to be showing you how to use parameters in there too. I should also mention too, we're going to be setting some time series visualizations based on this too, so we can see everyone's CPU and average, memory, free memory, and all that stuff on there too. And we can do that all through Tinybird, which is amazing. So we have our average time and nickname. Great. Let's do, I wish I could name this right up the front here, but what I want to do now is I want to set up a query that's going to show us all of the people who have CPUs that are below 20% of free memory. So we're going to do select from average, by time and nickname. And we'll set up a where clause on that where free on average is less than 20%. So these are all the computers that are running that have less than 20% free memory left on their computers. We can even hit something like create API endpoint. Actually, you know what? I'm going to rename this first. We should call this like below threshold free memory. There we go. Like, if we just write a word and it just doesn't look right anymore, because that may or may not just happen to me, we're going to create an API endpoint based on this. And with Tinybird, this is so cool because, right, what we've been able to do is pull in Kafka data. It took seconds, right? We just authenticated, pulled that in with Confluent, and we set up some example API queries, and we're able to filter on that data, specifically on, Datadog like infrastructure monitoring queries. And then we were able to hit a single button that create API endpoint, and we're able to output an API endpoint that you can use anywhere. And you can use that JavaScript, HTML. Here's a curl command. And you can even get that data in JSON, get a CSV list from that data, ND-JSON or Parquet endpoint. I love this though, because I can just show you with HTTP, we can hit this endpoint. We just downloaded that in Parquet, which I actually don't want right now. I want to actually just get this out here. So you can actually see all the data in real time from our laptop checks, and specifically from our below threshold. So these are all of the computers that below our threshold for 20%. Which you can see here. And these are being updated in real time. So we keep refreshing, right? We're going to see that data reflected in real time as that data is currently streaming in through Kafka into Tinybird. So boom. I don't know. We were kind of dinking around here, exploring a little bit, but that took about 15 minutes to get set up from authenticating with Kafka, importing everything, writing some streams to producing an API endpoint. And again, the hard part with me using a Kafka stream is actually using that data. Right? We can pipe it into something, but you typically have to build your own API endpoints from scratch to actually use that data in other sources. And of course, HTTP endpoints, REST endpoints, ubiquitous. You can use those pretty much anywhere or in any type of application. Okay, this is actually something I just learned this morning though. And this is super cool. We can actually use something called query parameters in Tinybird to set up API endpoints with different query parameters to adjust the threshold. So this is hard coded in, right? With this API endpoint, hard coded in, and it just gives you data from under 20%. But again, I just learned this. This is super cool. You can use query parameters on here to make an API endpoint that has variables within it to adjust the queries that are coming in and out of Tinybird. So I want to set up a query parameter, and on the free threshold, I'm like, where is that? Called free threshold. Okay. I'm like sitting here, I'm like, am I spelling threshold right? But I think that's right. We're going to default to 20, and we can write a description on here as well. So this is going to be alert when below threshold. And we're going to, this query parameter is not going to be required to get this to work. Okay, so let's see if this works. Okay, so this is on 20. But here's the cool part. We can adjust this in here. Duh. So I think we had like, if we have 40, of course, we're going to have more kind of coming through here. You can see that we have up to 40. But that's not the cool part. The cool part is actually on our API endpoint. So I'm going to, and you can see here, now that we've created the query parameter, we have a new parameter on on our endpoint that allows us to adjust we can adjust the query in real time. So let's say you're sending this out to a data team and they want to change it. Historically, they have to come to you and you'd have to change the query in here, or your data team has to adjust some queries, SQL queries to kind of adjust that. But if you want to make adjustable endpoints to query this data source, you can control what data they're getting from that endpoint. So let's actually try this out in real time. So you can see here, we have up to 40, we have 37 here. But if I change this query parameter on here, and I know it's still small, but I'm going to change this back to 20. Boom. That same endpoint, now we're able to adjust in real time what kind of data we're getting back from that, which is amazing. I just learned this morning. I think these are super cool and super powerful, and it allows you to make, traditional REST endpoints with some query parameters that are super powerful and allow you to like query and use data however you want. Okay. Cool. So we've got our checks here. Great. I think the next thing I want to explore a little bit is using this data that we just set up to playing with using some time series data on this. We've been running this data for a couple hours, so we don't have a lot of historical data yet, but I do want to. So this is events from Tinybird. That was our Kafka endpoint, and we get to choose the endpoint we want to use. Obviously, with time series, timestamps make a really great natural way to, set up endpoints on that. So let's play around a little bit with some endpoints. So first up, let's make a graph of the free memory by OS. I'm not even sure if anyone's running Windows or Linux on here, but we're going to find out. So we have our data coming in from that Kafka stream. We're filtering on the date column. Our timestamp is coming in from Kafka. And what we want to visualize is round the average free memory. So that's mem free. And then divide by average memory size. Okay, great. I always have to remember, all right. We're rounding the average memory free divided by memory size. We're multiplying by 100 in order to get that percentage, and then we're rounding to two decimal points there. Okay, where did I mess up the, I think I have too many here. There we go, great. And we can adjust the different bars on here too. You can see here I was running some tests here last week on the same thing, but we can filter on something a little bit more recent too, last 7 days. And I think I'm just going to do the data that's coming in from today. 15 seconds, maybe I'll do a minute. Bars, can we do 5? Okay. I want to see some exciting data here. Bar charts, last 2 hours. Maybe we'll expand this out a little bit. There we go. Oh, yeah, there we go. Okay. And you can actually see some of the output here, too, of each of these. So on the bottom, we have our times. And then on the y-axis is our average memory, free memory and memory size coming from the events, which is super cool. So we get to see kind of average across all of the Tinybird employees and what they're using. Let's try. Does 30 minutes work? Nope. 10 minutes. Interesting. All right, cool. That one's, maybe people playing with this longer. No. So this is like what's been running since I asked the employees to run it to right now. Looks like that was, I have no idea what that was. Maybe that's just a rogue event kind of running over there. But we can visualize that in real time. You can see it and you can embed that too, which is great. I'm just going to do a couple quick other ones here. We're going to do the same thing. We're going to do events from Tinybird. Thank you for the autocomplete for me mistyping it. We're going to create a new one here. And we can do things like average, disk. Now, time zones. Yeah, time zone. Oh, time zones are hard. Yeah, because we're not really filtering by time zones. It's whatever the CPU is reporting as the time zone. That's a good point. Thank you. Chat was just reminding me that time zones are really hard, and you're totally right, Jesus. They totally are. Yeah, they. That is exactly what's going on. So we have obviously Tinybird's based out of Spain. We have a lot of people from Spain who are running this too, but it's going to be reporting their local time on them. So that would make sense. It must be really late wherever someone's running this right now. But you can totally do that. Again, time zones are tricky, and you can do queries to kind of adjust for that or standardize them across, a standard time or whatever, or normalize them to some time zone that you want or whatever. But let's go through here. So we're going to get the let's get the average free disk size. So we're going to get the average disk free, right? By the power of 124. Try to standardize that to 3 decimal points. I think that's what it is. And we're going to run that. Great. All right, we'll get all those. Can I do 1 second? What does that do? Oh, dang. All right, cool. So that gets us, I think that's to the gigabyte, 124, because it's probably reporting in bytes, I think is what's coming back from that command. I'd have to double check on that. That's giving us the, Yoast says we should only allow customers from one time zone to submit to our Kafka application. I think that's a really good solution. Sorry, everyone else that isn't in my time zone. You're going to have to figure it out. So yeah, you can do by average free disk over time. And then lastly, we can see if that changes, decreases, increases, or whatever. This could be really powerful, especially if you're managing a server farm and you want to replicate this mini Datadog on your own. Again, this could be really useful for you in the real world. Datadog's amazing. They handle a lot for you too. But if you want to have more control over your data, this could be a really great use case for you for using that. And again, with Tinybird, we don't charge based on the data you're saving in Tinybird. We just charge based on the amount of data you're processing through our API endpoints and queries on there. And playing around with our free tiers is a great place to get started. Hint, hint, sign up. And you don't get charged for playing around with demo queries, even if you're using production data. So only for whatever you publish publicly. All right, let's make a new one. Oh, so let's do another one. Events from Tinybird. Let's do one more. We'll do a timestamp. Cool. Create. And let's do one more. We'll do free by nickname. So let's do our average memory free. We're doing the same thing. Power 124 over 3. Now, here's the hard part. I can't remember. Line, bar, group limit, 5. Oh, all right, great. Last 7 days. We're going to do last 6 hours, and we can check this out. Can I change this to something else? No, these are just to the time on here. No, I can't remember how to do group. I actually see the nickname on here, but oh, okay. Jorge says we can change it to the underscore timestamp. The underscore typically denotes kind of the default created by Kafka's timestamps on there as well. Okay. Oh, that's true. So that standardizes a little bit better. Thank you. I appreciate that. And let's pull that. Ooh, that does look better. Thank you. Amazing. Yeah. That's amazing. Great. Okay. Cool. I do want to show here one last thing. So we've been playing a lot with the Tinybird UI, which is really useful, and you can make all the stuff in real time with that. But I don't know about you, but I personally prefer using this, like writing my code on Visual Studio Code. And you can actually do that with Tinybird. Using the Tinybird CLI, you can actually go ahead and pull in everything. So I guess I could turn aside here what I want to do. Okay, actually, you know what? I'm gonna make a new window here, and I'm actually gonna pull in the data from, let's see here, Tiny, and we're gonna go to what is this? Mixture. We call this like a mini data dog. And I'm going to open that window actually in code. Great. All right. So we have our mini Datadog here. But what I'm actually going to do is set up Tinybird to run on our local. So I'm going to go through actually setting up the API endpoint from scratch here. So we're going to build out an API endpoint. Actually, you know what? I think I might be able to do this with the other one. There we go. I'm going to actually blow up my Tinybird config here, and what I'm going to do is set up Tiny. I'm going to authenticate with, let's see here. Let me make this larger so everyone can see. All right. And I'm going to bring in my auth tokens, and we're going to authenticate here. So what I'm going to do is basically pull in everything that there we go. So we got our Tinybird authentication here, and then I'm going to actually do Tiny. I think I can just pull it in, all the data that's in there. So can I make this a size that's more reasonable for me to read? You can see here I'm actually streaming that data in real time up here. And there we go. Okay, so you can actually see we were able to pull in all of the pipes that we just created. Whoops, that's one that we're going to do next, which is great. And we're going to actually set up a new pipe here. So I've written one here that does some similar work on here, but I'm going to actually throw that up. So I think we can do Tiny pipe data, and then I'm going to do laptop stats. Oops. Per user dot pipe. Why is that not doing what I want it to do? I'm just going to see what we have access to here. Tiny. Oh, I know what the problem is. I'm not in the right. So I'm going to do infrastructure monitoring. There we go. Okay. And I'm going to try. I think I got authenticated there correctly. No. Oh, all right. Next up, I'm going to reinstall this script here to see if we can get access to everything. This is the part I was kind of playing around with live. So let's see what we can do here. We're just going to reset up our Python environment on here. So I'm going to reactivate a Python workspace. And then I'm going to do a pip install. I think it's a Tinybird CLI. Let me check here. Great. Tinybird pip install Tinybird CLI. So this is going to allow us to, there we go. This always works. And I'm going to re-authenticate one more time now that we've just installed everything. It's asking for the region that my Tinybird cluster's in, then my admin token, and boom, now we're in. I'm just going to run tiny to see if that works correctly. Oh, weird. That booted me out again. Okay. Oh, I know the problem. I have an alias set up locally that when I run tiny, it takes me back, and it should be TB. That's the problem. Okay, so TB, not tiny. My bad. So now I'm going to actually take a look at this pipe that we created over here. Pipe data, I think it's laptop stats per user pipe. Invalid pipe name. Why is that? What did I do there? I have like a weird I'm just going to rename this laptop stats. Let's see what happens. Invalid pipe name. Okay. Just do. I'm going to try and be one of the other ones. Laptop check and see if that does anything. No. I wonder if it's because I'm mixing. This is like set up with the other demo. I wonder if that's just like it's like slightly different naming conventions and something on it, which might be true. Oh, I think it's because I'm using a different event name here, which is totally fine. Yeah, we're going to see here what I can do. Oh, drop the pipe. Thank you. I see Cameron's yelling at me in the Slack. Okay, great. This is great. Laptop stats per user. Let's try that. Nope. Huh. Let's see here. I'm not sure why that's not pulling through. But point is, you could still. Actually, you know what? Maybe I'll try this. We're gonna do TB pull. I'm gonna pull in all the latest stuff on here. Okay, so I pulled in all the other ones that we just did. Great. Data sources, amazing. Exploration pipe, that's the one we just did. And I'm going to try this one more time. Otherwise, I'm just going to say, you know what, did you push the pipe? Let me try that. Tinybird push. Okay, good. Oh, this is good. Okay, so it's giving me an error. That's good. Laptop sets per user on line 29. Let's check that out. Okay. We have a where clause that is freaking out. Oh, I know the problem. It's because we're using blings here. I use inconsistent here. Okay, let's try this. And then worst case scenario, I'll just blow that up and we'll. But we're just doing some live development here. You get to see the blood, sweat, and tears that goes into real programming, which I think is like great. Failed at line 29. Okay. So it doesn't like where. I'm going to make this a little bit bigger. And I'm guessing I have some sort of incorrect some sort of incorrect. Yeah, it doesn't like my if defined handle. Can we do a nickname? I wanted to see if I could filter by. Okay. Doesn't like the where 1 equals. Oh, thank you. Then put an and in the if defined. Is it before? Let me double check it because I have a. I'm just going to see how to write my where clause. Make sure that's right. So we had the where clause we did before. Okay, where Cameron says where 1 equals 1. Oh, is it like no spaces there? Is that what you're saying? Okay, where and nickname. This? We'll try it. That doesn't feel right, but yeah. Can't put a where inside of an if defined. Oh, okay. I see what you're saying. Okay. Where nickname. This is the part we're playing around here. We're just goofing around. Where 1 equals 1. Where nickname. I'm not sure what that means. 1 equals 1. I'm so sorry. Okay. Nickname. That probably won't work. Where 1. Okay. Okay. I feel like everyone's just like yelling at me in the chat. I'm not sure exactly where I'm messing up here. Same as where true. Oh, okay. I see. So just like does it. Yep. And now you need and. Okay. Great. That work? Nope. And nickname. Equals. Like that. I wonder if we can we do it like that. Got a Slack DM. Oh, thank you. Appreciate that. I'm just going to slap this in here and see what happens. Where 1. Isn't debugging really fun, guys? I thought so. Okay, then we're going to reformat this. Equals. Great. Oh, I see what y'all are saying now. So then we're going to throw that in there. Okay. Let's see here. Where did I mess up now? Oh. Okay, line 37. Hey, we're moving. All right, I'm gonna comment this out for now. Let's just do the 1. Just for fun. We're just gonna show. Nope. All right. And we're just going to delete that. Okay. Laptop stats per user. Line 37. That doesn't feel right. Okay. We got that saved. I wonder. Looks like it's an old line number on there. It says string. David, actually, I did mean sting, like the yeah, like the police. All right. I'm about to give this like another 30 seconds, then we're moving on. Let's see here. Select star from filter data, which is above. Okay. And why is it freaking out about line 37 when there's only 29 lines of code in laptop stats per user? That I don't know. I wonder if we can do like, I may just do another poll here. Everything already exists. That's totally fine. Push. It doesn't like it. Okay. You know what I'm going to do? I actually have another idea. I want to just like see if I can get this working in the Tinybird app. Can be a lot faster too. I'm just trying to show that it is possible to do that on there, but let's do another one on here. So let's do laptop checks and filter data. Actually, maybe we'll do a new pipe here. Actually, you know what we're going to do? Select star from, and I'm going to take our code, copy that in, and then we're going to it works. I don't know. I don't know what's going on with that, but okay, that's good to know. Basically, we're just doing a filter on here, and I forgot my full name was Joe Karlsson, but it allows you to make a endpoint that allows you to filter by users on here. I don't know why that wasn't working, but we'll get that fixed right away. We can assure you we'll get that fixed right away. But looks like that was correct. Thank you to everyone in chat for helping me get that query out, which is really helpful. And I learned about the where one clause. That's great. The where true clause. Yeah, weird. Okay, interesting. Where can we do? Is it nickname? Defined, cool. And I was just going to check up here if we have a nickname actually coming through. We do. Yeah, it must have been. I think, yeah, it looks like something got messed up with like it going up or not. I'm not sure. Still, interesting. Interesting. Can I try? Handle, great, filter by. I'm going to try that. All right, whatever. Still interesting. You can make endpoints. You can send them up locally from the CLI. It must have been something messed up with kind of playing around different environments. I'm assuming it's something I messed up in there, but we figured it out as a team. And if you get stuck on anything, you should totally join us on the Tinybird Slack community. It's super friendly, awesome place to go to learn about how you use Tinybird, ClickHouse, creating API endpoints, scaling. If you're having production issues, just want to chat with an engineer, developer advocate, or someone that works at Tinybird, we'd love to have you there too. Okay, cool. Let's see here. So I think that about wraps it up for today. We laughed, we learned, we cried, we sweat, I bled. We learned a lot about Tinybird, and we built an infrastructure monitoring tool using Python, Tinybird, ClickHouse, and Kafka. I hope you can see too that Tinybird makes a really great data ingestion for Kafka, and it allows you to easily write SQL commands to create API endpoints, actually use that data. We didn't get any of this today too, but another thing that Tinybird does really well with Kafka data that's streaming in is hydrating that with other data sources. I just worked on a demo of streaming in real-time e-commerce data and hydrating that data with a data warehouse, specifically Snowflake. So you could hydrate all that product data with the real-time transactions coming in, right? So you get like a product ID, you go to Snowflake, or a product ID from Kafka, and you go to Snowflake, go find that product ID and hydrate that with that product's information. And then you can create an API endpoint from that, which makes it really great. But I think that about wraps it up for today. Again, thank you for everyone who joined. Hope we learned something. And thank you for putting up with me exploring here a little bit today. It's tricky. Keep an eye on DMs and trying to troubleshoot in real time. And it went pretty smooth though for the most part. But yeah, this is a fun demo. If anyone want this code, we'll be posting it up on our GitHub here soon. I'm going to be blowing up those secret keys here in a little bit. But if you want to set up your own Kafka stream and play around with this, go for it. We'd love to help you with that too. But I think that's about it for me today. Thank you again, and we'll chat with you next time. Bye, everybody.